Hey, it's time for Inspiration Mudworks, and in this week's video, we're going to machine these handles. Let's take a look at the CAD that we used for this tool. There's a couple parts to it. Right, we've got the part itself, right, the crank arm. There's the soft jaws we had to do, and then we'll take a look at the different tools that we use because there were some people who asked about that, the recipes that we used for that. Speeds and feeds that we used and things of that nature. Again, this is being tailored for the 440 as opposed to running it on the VF2, which would have a much more aggressive recipe for this. But let's take a look at that. Alright, I guess before we get started, let's take a look quickly at the final product so we can get an idea of what we had to do. This is the first operation that's held in the vise, like this, right? This is up. So we come in, we're using the shear hog to do the facing and the roughing. We come in with a 3/8 Imco end mill and clean up the pockets here, at which point we flip it over, put it into the soft jaws, and come in and we deck the rest of the material off, the excess material with the same shear hog. We drill our hole in here, we do our engraving, and then we come around and finish this up with some chamfers. Alright, so let's take a look at things like our speeds and feeds and all that good stuff, because I know I've had a few people ask about this and I want to make sure that I'm covering everything here. So there's a couple of things in here that I did. So we've got the handle, which is pretty straightforward. You know, we've got a counterboard hole here, and then we flip it over, and then we've got the other work to do, you know, clean up and then engraving, right? So to do that, we have a couple of things. So op 1, let's take a look at op 1. This operation 1 let's make it look like it would be, that's pretty close. So in the jaws, in the vise, right, come in here, facing operation, I'm using the shear hog, and you notice I try to keep this, and actually I changed this one should be suppressed as well. Okay, so yeah, so basically I try to do it by tool, right? So I've got the shear hog comes in and does facing, and then we do some contouring, right, and you know, do my roughing. So let's take a look. The shear hog here, we're running at 10,000 RPMs, right? For a facing operation, it wasn't taking a whole lot off. When I set up my model here, I only did a 10 thou offset from top, so nothing. You know, it wasn't taking a whole lot off of here. So yeah, the shear hog actually gives surprisingly good floor surface. You know, so whenever you're seeing the faced pieces on here, it's, you know, that's coming from the shear hog. The other thing, let's look at the 2D contour, because this one is pretty important. Actually, I need to change this because I thought I changed this already. Interesting. Let's take a look. Okay, so we're doing multiple depths, 0.1. That's fine. Stock to leave. I left 10,000ths on the sidewall, but I did. I went 10,000ths below. So I went to 510 as a full depth here. Well, I was doing a 100 thou per step down there. When you look at that, let's go back to our feeds and speeds. I brought that down to 4 thou per tooth. It's a single flute cutter. Lead in actually should be the same as the cutting for. Not sure why. I thought I had changed that in here. And then ramping, yeah, that's actually probably not a big deal. All right, pretty straightforward. Again, 10,000 RPM. Yeah, you could probably do 8,500. The 10,000 was a little overkill sometimes. Sometimes I run this on, you know, instead of stun, I run on full kill. And you can see, yeah, I got phenomenal material removal without pushing too hard on this one. Now you guys saw later on, and then maybe that's where I changed. Yeah, I must have changed it here. But I had to make some changes to to how hard I was doing my facing operation in there. I'm boring. I'm using an IMCO 3-flute end mill here, and it works really, really well. I don't know if I've got all the information. Yeah, I don't think I've got, let me see if I've got it in my tool library. I don't know if I've got all of the information on that. Actually, I use a 1/4 inch and a 3/8 inch in here, and both of those are from IMCO. Yeah, I don't have the full information in here, but I think what you guys were most interested in, or I know what a couple of you were interested in seeing, is speeds and feeds. 90 inches a minute on that one, right? 3 thou per tooth. It's it's blasting in. There's no problems with that. I did tell it to leave 10 thou. I'm using a bore operation on this. I told it to leave 10 thou on the sidewall for cleanup. This particular wall is very important because we're doing a press fit with those pins, and so I've got to have a really really tight tolerance here. One thing that I did have to do in other portions here, and actually it'll show up in the next one here in this contour, I had to do some specifics on the lead-in. Everything else was the same, but here, this is where, remember I told you I had to dial in and keep that really accurate? Well, I had to tell it to leave 5/10 in order to get the bore that I needed. And the other thing that I had to do is I had to tell it where to come in, because there's not a whole lot of space in there, and trying to do, I could do a ramp, but it doesn't make sense to spend all that time when everything's gone at that point. So doing that and then changing my lead in and lead out to 10 thou, just enough to get it off the wall. Let's see, what else did I do on this one? Chamfer is pretty straightforward. This is a 1/4 inch Chamfer Mill. I think this is a Lakeshore carbide. It's a 45 degree, or I guess 90 degree included angle. Nothing spectacular here. 6,500 RPM. I was running at 25 inches a minute. I've actually run these at 8,000 and run it a little bit faster, but this seems to give really a good quality on this one. One thing that you want to make sure on this is that you've got your doing a chamfer tip offset, right? So you don't want to cut with the very tip of the cutting tool. The default is actually 40 thousandths. I tend to move it around a little bit. So in other chamfers, you'll see I've got it at 60 thousandths. Sometimes it's at 50. I try to move it around so I'm not using the exact same part of the cutter all the time, right? It's not just about making sure that you've got enough velocity on the flutes, but also so that you're not just wearing out that same spot all the time. So that was op 1, right? Not a whole lot there. Again, we clean it up, we rough it, and bring these to spec. Before I could do op 2, and actually I had a special one where I had to do an undersize bore, so I just duplicated that, and then I changed some of my settings in this contour. So then the soft jaws. Let's turn the soft jaws on. Right. Can't see anything right now, so let's move this around. All right, so here's our soft jaws. Pretty straightforward on making soft jaws. There's a ton of videos out there on how to make soft jaws. If you don't know how to make soft jaws, leave me a comment. I'll make a video on how to make soft jaws, but it's pretty straightforward, right? So let's take a look at that. I'm going to turn the handle off for a minute. Oops, let me turn that sketch off too. And so we can see the soft jaw. One thing that I see people forget all the time is they leave sharp edges in here, because what you're really doing is you're taking this handle and you're cutting it away, right? So you're taking, when you make the jaws themselves, you're not actually you're not extruding it into where the handle is. Well, that would leave these sharp edges, these sharp points. Well, that's a good place for the tool to get off a little bit. It can get burrs or things like that. So I always just put a tiny little radius in there. It's not hard to do, right? Just put a little radius in there, and easy to take care of. So go in and remember, you've got to have a known distance between the two sides. I used that 1/4 inch tool. Came in. Now this one, I wasn't trying to push it. It's a 1/4 inch tool. I was using some of the factory settings for this one as far as material removal rate. But one thing in here that I wanted to point out, I typically, when I'm looking at my optimal load on the 440, let's look at the expression because I changed this quite a bit. I use tool diameter because I'm doing a full depth of cut on this one. Tool diameter time, it's basically 5%. It's not a heavy engagement, right? It's not a whole lot on there, but it comes out really well, and you can run fairly fast cutting speeds. So at that engagement, you can really cook with it. And what I find is I get good material removal at a good balance there. So I'm not. I think I've only broken one of those. And now that I've said something, I've jinxed myself, but that's okay. And again, 10,000s on the wall, and I come back. So basically, I do each one. Right. I did it as separate tool paths so I could restrict where it was going, and then come in, do my contours. The contours where I actually do those little radius in there, right? And then come in and do chamfers, right? Get it cleaned up. I did an upper chamfer, and then because I could, I did the lower chamfer as well. And I think this is one where I did it. Let me see. Yeah, you can see I moved the tip to 60,000s instead of 40,000s. All right. So we made soft jaws. We'll turn the handle back on, and now what's left to do on the handle? Well, the first thing we do is we face it. Now there is 250 thousandths of material there, right? So we need to do some real roughing. Excuse me. And you notice I brought that feed rate way down on this one because, hey, at 100 thou, and this is where I was adjusting the slider in that video, but I realized at 100,000 depth of cut, full engagement like that, I needed to slow it down. I typically, again, on my or I guess I was at what's that, 70%, 95%, so 95% engagement. So yeah, that one was pushing it. So, but one thing that I did is I looked at how much material was left, and I wanted to make sure. So I've got 100 step downs, but then I did a finishing step at 50 thou, right, to make sure that I had a nice even distribution there. So when you look at that, it comes in, it does those first two, and then that last one I get. It's a 50 thou depth of cut, same. So half the engagement, but the same feed rate. I get great floor finish. I think in the video I didn't show I switched from using that 1/4 inch tool to do that part, to do this hole, to doing it with the drill. It was just a better way to do it. It was fast, a whole lot faster, and it made more sense. I was drilling a hole. Why was I doing an interpolation helical interpolation for a hole? So drill it. Where you can drill, do it. Engraving. This is a neat one because I'm cheating, right? I actually created this tool. Let's take a look at my tool library. So let's look at tool 17 and 18. Where is it? Oh, neat. I don't have it on this one. It hasn't refreshed yet. All right, well, let's do it here. All right, so what I did was I created a new tool, but I faked it out. This is actually a ball mill. It's a 3-flute ball end mill, 1/8 inch. And it's a little stubby thing. It doesn't stick out very far. I think it's 3/8 length. But I told it was a chamfer mill because what that allows me to do is it allows me to run this chamfering process. And so in doing that, I was running that same 6,500 RPM. I was doing 10 inches a minute. I probably could push that faster, but it does a really nice job on this. So that is what I went with. And I left the defaults. I didn't touch anything else. I basically, with the engrave function, it handles the heights and all kinds of things. So yeah, it came in and handled that like a champ. And then the last operation is that cleanup, right? Do some do the chamfer around there and get it all cleaned up. So that is the explanation of speeds and feeds, and how I got my shiny parts. I hope this was helpful to you guys, and I will talk to you again soon. Alright, so let's take a look at the CAD that we used for this video. Let's try this again.